Hi, I'm Paul Brodie. We're back. Mitch has been away for a couple weeks. He went to France. So we're going to resume operations here. Thanks for tuning in. I have some Aramaki parts here. This is for the big bore motor, so I thought I'd show you. So what's on the menu today, in my mind anyway, is to show you around here what's going on. And then I might put this in the lathe and take off a cut because these need to be lighter. These are the rocker arms. And then I thought, if that all goes well and we have time, we would see if this bike will start. It apparently has a spark. You just had to turn the motor over fast enough. When I was using my hand, it wasn't fast enough, but it does have a spark, so there was nothing wrong with the vape ignition. So hopefully that'll work out well. Okay, I got some parts out of Germany, so I'll show you around a little bit. These are the valves. So this is a stock intake valve. On the stem, it's 7.5 millimeters. This is 6.5, so it's a little lighter, and it lets the air move past a little easier. You can you see how it's bigger? It's, I think it's a 46 millimeter. This is the intake, 7.5 for the stock. This is 7. And you can also see how it's bigger as well. So that's good. And titanium valve caps. These are very light. And I got the keepers that match each of the valves. These are the valve springs. And this is a stock spring. These are the racing ones. And why this one is 5 millimeters shorter, I have no idea. I'm not happy with that. So I was told that it's very hard to find Aramaki valve springs, so I just have to use what I've got. But I want 2 springs the same length, so I'm going to have to look into that. And then I got a cam here. This is the stock cam, and this is an N5 racing cam. Now, in the bikes I built previously, I had an N6 cam, and that's a little higher lift. So how you find out what the lift is, let's just have a look here. If you put the caliper on the base circle, this is the base circle here. Okay, let's do the stock one first. So I'll put it on there. I'm going to zero it out. And then when you go to the lobe, that's the lift. So this has a lift of 6.26 millimeters. And then on the race cam, it's not a full race cam. It's more for mid-range power. That's what I'm told. So it's got a lift of 7.4. So it's about a millimeter more. So looks fine to me. So we'll see how that works out. And then these are the clutch springs. This is stock, and can you see how the racing spring is about another 5 millimeters longer? I measured the wire, and they're both the same. It's like 83 thou, something like that. So these ones are just a little stronger. And this is the liner. So it's going to fit the piston, okay, we haven't talked about the piston. This is a stock piston. So this is out of the 60s or the 70s, and you can see how the skirt is a lot longer, and it doesn't have a 3-piece oil ring. It's just a 1-piece oil ring, whereas the new ones, they have a 3-piece. So this is stock piston. This is a racing piston. It's a 74.5 millimeter, I believe. And then this is the piston I got out of Germany. And I was expecting a new piston, but I got a used piston. Mitch is going to show you what it looked like when it showed up here. And I was expecting a new piston, so I was a little disappointed in that. I'm told this piston has 15 hours on it, so it could work, but I wanted a new piston, so we'll see what happens. This is the liner. This is the stock liner, and you can see how it's the right size for the stock piston. This one's a lot larger. It's 5 millimeters larger. That's what puts the size from a 350 out to a 392. So this has to go into the muff, so it's got to get bored out. You can see how much has to come out. It is quite a bit. And probably the muff needs to be a little shorter because the rod's probably going to be shorter as well. So there's some a machining to do. And here's the cylinder head. And can you see how this muff, this is the stock muff. No, this is the liner. I'm calling it the wrong name. That's the muff. This is the liner. Can you see how that fits in there? Well, the new one doesn't fit in there because it's too big. So this has to be opened up. So years ago, I made up a fixture, and that's here. This is the fixture that holds the head. And this goes... It's probably hard to imagine a little bit, but I'll take this off. This goes in the spark plug hole because that's what holds it down. I had to figure out how to do this. I didn't copy anybody or anything like that. So, see those two threads there? These Allen screws go into there. This rests on here. And then when the spark plug when this part is screwed into the spark plug hole, this Allen screw holds it all down. So that's basically how it fits, like that. And then this goes into the rotary table in the mill. And then I can take out a cut here. I need to take out a few millimeters. And then I'll also take something off of here because when I take a little bit off there, it increases the compression ratio. And last time I was doing this, I took about 1/16 of an inch off, and it really does bump up the compression ratio. So that's kind of my show and tell for what's going on here. It's exciting for me. I don't know about you, but I'm going to show you how this all works. And then these are the rocker arms. And I like to save some weight on these, so I made up a fixture. And I put this in the lathe, and we can do this now. So this goes into the 3-jaw chuck. That slides on. There's an Allen screw there. And then I take a tool bit that has a radius on it, and I machine from here to here, and then I flip it around, and then I machine from here to here. And then after that, these all need to be made a little nicer and smoother because you can see that it's a little bit rough from the casting and that. So what I'll use for that, a spiral roll. And so the spiral roll goes down into here like that, and it comes up, and I make this a little bit narrower. Can you see here how this fits? This can be smaller, so I can take off metal like that because it only has to be as large as the hex. I don't need all of that, so it's going to be, that'll be made smaller. And you can see how that's part of the casting line there. And so that can all be ground off as well. So That's something else. That takes a little bit of time to make it nice and all that. So let's go over to the lathe, and I'll take some cuts. You'll see how the process starts, and then we'll see if we can start the bike. Thanks for tuning in. Here's the tool I'm going to use. It's carbide. It's 3/16, so it has a radius of 3/32 of an inch, approximately. So I'm going to make a mark so I know where to start. I think you can hear the hardness a little bit. And then when I come down here, I think that's about as far as I want to go. Making sure nothing's going to hit the tool post. Okay, that looks about right. Okay, so you can see how it's taking a cut here, and then over here, it's not. So, you know, the bore is in the middle because of the fixture. It's centered. So this is out of round, obviously, but it's a casting, so that's okay. And this right now is 35 thou over. So we need to take off another 15, 17 thou, something like that. All right, so that's one side done. I'm going to flip this around now and machine this side here. So this is basically how the process starts. If I take the belt sander, I can polish that smooth there, so that's good. Let's see if we can start a bike now. There you go. I lost the piece of wood holding the brake lever down, and so the degree wheel is making a mark in the brake lever. But it works. That's good. The ignition system is good. The timing is pretty darn close, about 35 degrees before top dead center. And needs a little bit of fine tuning, but we're on our way. That's a good step. Thanks for watching. Mitch and I like coffees. If you buy us coffees, it really helps our channel. Please like and subscribe. Next episode, we're going to work on the BSA Starfire. Thanks.